we have to do is set up a Kubernetes cluster. As we mentioned it previously, that the Argo CD need to run within a Kubernetes cluster, can't run by itself. So as you can see, there are a lot of Kubernetes control plane components. Once it's all green, then we can actually run the Argo CD. Itself, the Argo CD will create a lot of components, as they call it, Argo CD control plane, but it's not related to control plane in Kubernetes at all. As you can see from the namespace, there's a kube system and there's Argo CD in there. Once it's been set up, then the next thing that you can do is you can port forward from your host machine, let's say port 8080 to the pod, and then log in with admin. Unfortunately, it doesn't work. So you have to get a passwords one way or the other. The first way is you go to Kubernetes secret and you get the password in there. It's base 64 encoded, so you have to decode it. And the second way that we prefer it most of the time is from the CLI. Once you've got the password, you have to log in to the Argo CD. It's your option whether you log in from the UI or from the CLI tool, but you have to use the same username and password. Once we've done that, then we can see it's a blank new canvas. There's nothing in it. What we're trying to do next is we are going to deploy an application. It's a simple guestbook UI. It's just the UI. There's nothing else. We just need one instance. Let's say the replica is one, and then the image itself is hosted in Google Cloud Repository. It's basically just a Docker container. So you can create the application from the UI. You give it the application name, and then you give it the code base and the path. And next is you give it the destination where you want to deploy your app into. As you can see, the namespace is commonly different from the control plane, and it's also different from the namespace that we use for Argo CD. This is just for separation. We created a new namespace just to host the application. Of course, we are not going to do it this way. What we will do instead is we will use CLI command to install the application. First, we have to create the namespace for that separation. And once you have the namespace, then we can see how many namespaces are there. The default is the default Kubernetes namespace, and Argo CD, the one on the top there, is for Argo CD. The next 3 cube is for Kubernetes cluster, and the last one there is for the application. So here we're going to create an application using CLI command. We give it the code base, and we also give it a destination namespace. Watch what it will do. So once you've done that, it will create the application in the UI. You can also get the application details from the CLI. It will tell you all the exact same informations. The status of this application is out of sync, so the desired and the actual state is different, and the health check is missing because we haven't deployed anything. So in order to deploy, we have to synchronize the application. It's similar to deploy. You can do it both from the UI and also from CLI command. So watch what it will do the moment you sync the application. It will create a deployment replica set and a pod. Look at that, the one in orange, guestbook UI, within its own namespace. So it will create a couple of components in there. Once it becomes green, and then you can do the same thing. You can do port forwarding into that pod to see what the application will look like. Now that it's healthy, you can see the whole UI components here, and then we just do the port forwarding to check if the application is actually working. And Viola, that's the application. So next, what we will do is let's just kill the pod, kill the instance, see what will happen. So we only have one instance, right? One pod. So when we kill it, the application obviously will not run anymore. But what the Kubernetes automatically will do is Kubernetes knows the desired and the actual state is different, and then it spins a new pod up. If you go to replica sets, then you can see the first yellow is the first instance, and then when we shut it down, the second yellow in there is where the Kubernetes control plane detects it and spin up a new one. This will work for self-healing and if something happened to your application. But what if someone changed the configuration? Let's say someone changed the version number, or someone deploy a different binary, or someone scale it to a different number. Let's say if I scale it to 6, not 36. Yeah. So both the pods and the UI will be showing what I've done. So there are 6 pods running guest UI at the moment, but what I want you to focus on is the sync status, because the one that we set on the Git is 1. So the desired state is different from the replica set, from the desired state. So there are 6 spots in here. It detects the out of sync. If we want to sync it back to what we specify in the Git, we just have to run the same command, sync from the UI or from the CLI. But for this time, I'm going to do it from the UI. As you can see, it scaled it back to 1, which is nice. That's actually the pull mechanism that I mentioned before. Let's take it a little step further. Do you have to press the button all the time? No, there is a feature here called auto sync. You can even set it based on a specific time frame. So for example, you can enable auto sync when it's not busy. Let's say when it's midnight, when the configuration is different from the actual state, it will do the sync automatically. So you just have to enable it here, or you can do it from the CLI. Once the auto sync is enabled, let's scale the deployment again. Let's go nuts to 10. And when we scale it, you can see it goes to 10 pods and then scale it back to 1. So that's the feature. That's the magic of auto sync. So this command here that you see on the CLI is actually how we enable the auto sync from command line.